Very large reptiles already capable of doing damage may be more dangerous than anyone thought. The plot is playing out right here in Florida.
When you look at these images, it is hard to believe that the Everglades was once one of the most protected wild areas in the United States. Yet today it is collapsing in a way no one expected. Giant Burmese pythons are wiping out the animals that once filled this landscape, and an invisible parasite is spreading even faster than the snakes themselves. Recently, scientists uncovered a surprising truth, a missing piece that explains why every plan to stop the damage has failed for so many years. If the predators, the parasites, and the land are all changing at the same time, what future is left for the Everglades in the years ahead? The Everglades was once a world that felt almost untouched, a place where water moved so slowly across the land that people called it a river of grass. When the sun rose, the sky filled with the wings of herons and ibis, and the sound of life echoed across more than 1.5 million acres of wetlands. Every inch of this landscape seemed alive, from the turtles sliding into the water to the deer stepping carefully through the marsh, and the entire system worked together like a single living body. Families who lived near the Everglades relied on its clean water, and the wetlands absorbed floods long before they reached the cities, acting as a shield that protected millions of people. For a long time, the balance here felt unbreakable, as if the Everglades would remain wild forever. But that sense of safety was the very thing that made it vulnerable. The warm air that never truly cooled, the thick humidity that hung over the swamp, and the shallow water that covered miles of open land created a home that almost seemed designed for a creature like the Burmese python. The grass grew tall enough to hide a moving body, and the tangled roots along the riverbanks offered perfect spots for an ambush. When night came, the heat barely faded, which meant a python could stay active while other predators slowed down. Food was never a problem. Birds nested in huge numbers along the marsh. Small mammals moved constantly between patches of dry ground, and wild hogs roamed the forest edge. Even young deer wandered close to the water, unaware that something new had arrived in the shadows. No local predator knew how to deal with a hunter that could swim, climb, and stay, still long enough to vanish completely. By the time people realized what was happening, the Everglades had already opened its doors to an invader. The path that brought the python here was not a single event, but a chain of choices and accidents. During the 1980s and 1990s, pet shops sold tiny pythons to anyone willing to pay, and their size made them look harmless. Owners could hold them in one hand without knowing they would soon grow longer than a car. When the snakes became too large and too strong, many people drove to the edges of the wetlands and let them go, hoping nature would take care of the problem. Then Hurricane Andrew arrived in 1992. The storm tore through South Florida with winds that shredded buildings and scattered animals into the open wilderness. United States Geological Survey researchers later confirmed that pythons escaped from private facilities destroyed during the storm, adding another wave of snakes to the growing population already hiding in the swamp. Once the pythons entered the Everglades in large numbers, nothing stood in their way. No native predator hunted them, and no environmental barrier slowed them. A single female could fill a hidden nest with 20 to 100 eggs, and each hatchling could disappear into the sawgrass before anyone knew it existed. Over the years, the population expanded until it stretched across South Florida, reaching numbers that scientists estimate between 100,000 and 300,000 individuals. The Everglades, once ruled by native wildlife, now held a newcomer that changed everything. The decline of native wildlife in the Everglades did not happen slowly. It happened with a sudden silence that spread across the wetlands like a shadow. For years, biologists drove through the marsh expecting to see the usual flashes of movement, yet the animals that once filled the landscape were disappearing without a sound. The most shocking evidence came from a National Park Service study in 2012, which showed numbers that almost no one believed at first. Raccoons had fallen by more than 99% in the areas where pythons were common, and opossums had nearly vanished in the same regions. Bobcats, which once hunted along the edges of the sawgrass, dropped by more than 87%, leaving the marsh without one of its key predators. These numbers were not theories or guesses, they came from real field surveys comparing animal sightings before and after the python population exploded. The collapse did not stop with mammals because the python diet reached far beyond small creatures moving through the grass. They hunted birds nesting in the wetlands and swallowed turtles that once helped shape the ecosystem, and they also targeted young deer or small alligators if the chance appeared. Every meal removed another important link in the food chain, and the loss of these links weakened the entire structure that supported life in the Everglades. Animals that once played roles in seed spreading, insect control, or soil formation were gone, and the effects spread outward like ripples across still water. This loss created what researchers call an ecological void, a space in the system where key species are missing and the balance no longer holds. Without raccoons or opossums to keep certain insects and small pests in check, some populations grew without control, and the wetlands reacted in ways scientists had not predicted. Birds that once relied on small mammals for protection or foraging cues struggled to survive, and predators that depended on those same mammals were left without food. Even the sound of the Everglades changed because the noises that once came from moving animals or calling birds grew quieter each year. People who visited the swamp for decades said the silence felt unnatural, as if something deeper than simple hunting or competition had taken hold. This silence showed how fast a single invader can break an entire food web, especially in a land that evolved without a predator like the Burmese python. Once the base of the ecosystem collapses, the upper layers follow, leaving the marsh without the energy it needs to recover. These changes forced scientists to rethink how fragile even a vast wilderness can be when one species removes so much life so quickly. Florida's fight to remove Burmese pythons began with a clear goal, because state officials believed that a large community effort could slow down the population. The Florida Python Challenge became the centerpiece of this plan, and the event invited anyone with training and courage to enter the Everglades and remove as many snakes as possible. Thousands of participants joined every year, and many brought boats, flashlights, and long hooks in hopes of making real progress. But official reports showed that most participants caught none, while only a small group of skilled hunters captured a few snakes during the entire competition. When the numbers were collected, the average result was usually less than 300 snakes per year, which meant the removal rate was far below what was needed for a population estimated at 100,000 to 300,000 individuals. This gap proved that the challenge raised awareness, but it did not control the python population in any measurable way. Because the public events failed to make progress, wildlife agencies turned to full-time professional hunters who worked year-round rather than for a few days. These hunters patrolled levees at night with strong spotlights, searched drainage canals, and traveled deep into remote marshes that were closed to the public. Their effort brought in more consistent results, and some teams removed more than 1,000 snakes over several years, especially during warm nights when pythons moved closer to roads. Even with this success, scientists reported that the number of snakes removed each month still could not keep up with the number of eggs produced by breeding females. A single large female can lay 20 to 100 eggs in one season, and the Everglades has thousands of breeding adults, which means the population grows faster than hunters can reduce it. Because traditional hunting methods could not match the reproductive speed of the species, researchers began testing technology that might give them an advantage. Thermal drones were considered one of the most promising tools because they scanned large areas from the sky, but field tests revealed a major problem. Burmese pythons regulate their body temperature to match the environment, so the thermal camera could not distinguish the snake from warm mud, sun-heated water, or dense vegetation. Images often showed nothing more than dark shapes and heat spots, making it nearly impossible to confirm whether a snake was actually present. To overcome this, researchers tried something very different by using large male pythons as tracking animals. Scientists implanted small radio transmitters inside these males, then released them back into the marsh during breeding season. Because males naturally search for females, the signal often led hunters directly to nests, and some of the largest females in Florida were captured through this method. However, each operation required weeks of monitoring and long hours of searching, which made the approach too slow to impact the overall population. After more than 10 years of combined efforts, the total number of removed snakes passed 23,000, but the python population continued to expand across southern Florida. This pattern led United States Geological Survey to reach a definitive conclusion that complete removal was impossible because the ecosystem was too large and the species reproduced too quickly. The only realistic goal was to reduce local damage rather than eliminate the species from the Everglades. If hunting, technology, and tracking snakes cannot stop the invasion, then what hidden threat arrived with the pythons that made the crisis even harder to control? The invasion of Burmese pythons created damage on its own, but scientists soon realized that something far smaller and far harder to control had entered the Everglades along with them. Relied orientalis, a parasite known as lungworm, followed the snakes from Southeast Asia and began to move quietly through the ecosystem. The parasite lives inside the respiratory system of snakes, and it attaches itself to the lungs where it feeds and grows. In the Burmese python, this parasite causes little harm because the python has evolved with it for thousands of years and carries natural resistance. The situation changed completely when the parasite reached Florida's native snakes because these species had no history with lungworm and no defenses to protect themselves from infection. Researchers from the University of Florida began examining tissue samples from native snakes found across different counties, and the results surprised even the experts. The parasite had already infected at least 18 local species, including black racers, rat snakes, and cottonmouths, and many of these snakes showed signs of inflammation and weakened breathing. Some snakes moved slowly and reacted late to danger because the infection limited the amount of oxygen they could take in, which made them easy targets for predators. Biologists noted that the parasite spreads through the food chain, which means a snake can become infected simply by eating a frog or a lizard that carries the parasite. This ability allows lungworm to move across habitats without needing the python as its only host, and this explains why the parasite appeared even in regions with few pythons. Once lungworm enters a new area, it can pass from one animal to another and continue spreading through the wetlands. Surveys revealed that the parasite existed in places where python sightings were rare, and this pattern showed that the parasite had already adapted to its new environment. The speed of the spread raised even more concern because the parasite reached counties far beyond the main python range, and scientists warned that the infection could reach central Florida if left unchecked. Unlike python hunting, which focuses on removing one species, lungworm control requires understanding an entire chain of animals that carry the parasite as they move through the swamp. This level of complexity makes the problem nearly impossible to solve, since tracking small amphibians and reptiles is far more difficult than tracking large snakes. Even wildlife health teams cannot treat infected snakes in the wild because capturing every snake in a region would take years and would not guarantee success. The danger is not only the number of infections, but the long-term impact on local predators that already struggle with shrinking food sources. A weakened snake population changes how energy flows through the Everglades, and this disruption spreads across the entire ecosystem. If native snakes continue to weaken, then mammals, birds, and even insects may begin to shift their behavior because the balance that once kept the wetlands stable is already breaking apart. The discovery of lungworm forced scientists to ask whether Florida was dealing with one invasion or two, because the parasite created a second threat that spread in silence and reached places the python had never touched. When Burmese pythons began to spread across the Everglades, many people wondered whether native predators could slow the invasion by turning the snakes into part of their diet. For a moment, it looked like nature might be preparing its own defense. Camera traps in the wetlands recorded a rare sight when a bobcat attacked a small python near a trail, and the footage showed the cat pulling the snake away with surprising confidence. Rangers also observed American alligators swallowing juvenile pythons in shallow water, especially during warm nights when snakes moved closer to the surface. There were even a few cases where Florida panthers killed young pythons while patrolling their territory, and these moments gave scientists a reason to hope that predators might adapt to the new threat. But when researchers analyzed the overall pattern, they discovered that these events were not part of a growing trend. Each recorded attack involved small snakes that were easy targets, while adult pythons often reached lengths of 10 to 15 feet and weighed more than many predators could handle. A bobcat can overpower a young snake, but it cannot fight a fully grown python that can crush or bite with alarming force. Alligators are strong enough to kill larger snakes, yet they rarely encounter adults because the swamp gives pythons too many hiding places. Florida panthers also avoid unnecessary risks, and most will not engage a large python because the fight could end with serious injuries. This means that even though predators do attack pythons, the number of successful kills is far too small to influence the population. Biologists monitoring predator behavior found that these animals continued to focus on traditional prey like raccoons, rabbits, and birds, partly because these animals are easier to catch and offer less danger. With the collapse of small mammal populations, native predators struggled to maintain consistent food sources, and this instability reduced the time and energy they could spend adapting to new prey like pythons. Studies showed no evidence that predators were shifting their diet toward pythons, and there was no sign that any species was learning to hunt them on a regular basis. Instead, these attacks were isolated reactions, not a coordinated push from the ecosystem. Even when predators managed to kill smaller snakes, the python population still grew because adult females produced large clutches that replaced those losses quickly. The Everglades functions as a vast maze, and predators cannot search every corner while pythons continue to hide, reproduce, and expand their territory. This imbalance makes it clear that nature is reacting, but the response is too slow and too weak to stop an invasion that is already deeply rooted in the landscape. Scientists now accept that native predators cannot reverse the decline of small mammals, nor can they stop the spread of pythons or the parasites that came with them. Their efforts resemble sparks in a storm, brave but too small to change the direction of the disaster. While the Everglades struggles against pythons and parasites, scientists are quietly working on a different kind of rescue, one that focuses on bringing back a species that once played an important role in the ecosystem. The eastern indigo snake was once common across northern and central Florida, but its numbers collapsed after longleaf forests were cleared and gopher tortoise burrows disappeared. Indigos depend heavily on these burrows because they use them for shelter, nesting, and protection during cold weather, and without tortoise tunnels, the snakes lost the safe spaces they needed to survive. As the forests shrank, The indigo population began to fade until biologists declared the species functionally gone from large parts of the state. Instead of giving up, conservation groups started a long-term restoration project that focused on rebuilding the foundation that indigo snakes require. Teams began breeding indigos in controlled facilities where each hatchling was monitored carefully to ensure strong health and natural behavior. At the same time, land managers worked on restoring longleaf pine habitats and increasing the number of protected gopher tortoise sites, which created a network of safe areas for future releases. The effort took years because the goal was to rebuild an entire environment rather than simply releasing snakes into the wild without proper support. In 2023, the project reached a breakthrough when researchers confirmed the first wild-born indigos in the restoration zone, and the discovery showed that the population was beginning to recover naturally. This moment was celebrated as a sign that the ecosystem could still heal when given enough time, patience, and resources. Indigo snakes are known for their strength and calm behavior, and they can eat many other snake species, including venomous ones like rattlesnakes. However, scientists stress that there is no evidence showing that indigos can reduce the python population because pythons are larger, stronger, and far more numerous than any prey the indigo normally encounters. The purpose of the restoration is not to fight the invasion, but to rebuild the original food web that once kept the Everglades stable. By restoring the indigo, researchers hope to support the network of native species and strengthen the ecosystem's natural structure, which has been damaged by years of decline. The return of indigos shows that recovery is possible, but it also highlights how difficult and slow the process can be when an entire habitat must be rebuilt from the ground up. The Everglades is entering a future shaped by changes that move faster than the ecosystem can repair, and each change pushes the wetlands toward a new and fragile balance. Burmese pythons keep expanding into new areas as they adapt to different temperatures, wider hunting grounds, and thicker vegetation. Lungworm infections spread even farther, reaching counties with few pythons, which means the parasite now threatens native snakes far outside the main invasion zone. Local predators try to adjust to these shifts, yet their slow response leaves the ecosystem without the stability it once depended on. Restoration teams work to rebuild habitats and support native species, but these long-term efforts cannot reverse the rapid loss caused by invasive animals and hidden parasites. Scientists agree that complete removal of pythons is not possible, so the Everglades must learn to survive alongside the forces that are reshaping it. The Everglades is not the only place facing a crisis where an invasive species slips into an ecosystem and quietly breaks the balance that took thousands of years to form. Australia experienced one of the most dramatic examples when the government released cane toads to control beetles that were damaging sugarcane farms. The toads multiplied at a speed no one expected, and they spread across the continent, poisoning predators like snakes, lizards, and quolls that tried to eat them. Today, millions of cane toads continue to move west every year, creating a wave of collapse that scientists still struggle to contain. New Zealand faced a different but equally destructive problem when invasive stoats and rats hunted native birds that had evolved without natural enemies. Flightless species like the kiwi, kakapo, and takahe dropped sharply in number, and entire islands had to be cleared and fenced just to save the last remaining populations. This effort showed how even small predators can reshape whole forests when the ecosystem has no defense against them. In Guam, brown tree snakes arrived accidentally after World War II, most likely through military cargo. By the time researchers understood the problem, the snakes had wiped out nearly all native forest birds, and the island's morning soundscape went silent. The loss of birds later caused unexpected chain reactions, including changes in seed dispersal and plant growth. This pattern revealed how a single species can alter an entire ecosystem simply by removing one layer of its food web. even Europe has witnessed similar impacts, particularly in the Iberian Peninsula, where American mink escaped from fur farms and began hunting local species like water birds and small mammals. Conservation teams have spent decades trying to control their population, yet the mink continues to spread through rivers and wetlands. These global examples show that ecological collapse is not limited to tropical swamps or remote islands, because the same process appears wherever an invasive species enters a system that is not prepared to face it. The Everglades fits into this global pattern, but its challenge stands out because the scale is larger, the predators are stronger, and the parasites add an invisible layer of damage. Scientists studying events in Australia, Guam, and New Zealand believe the Everglades will also require long-term strategies that combine removal, restoration, and strict prevention. They warn that recovery often takes much longer than the initial invasion, and some species never return once their populations fall below a critical point. The crisis in the Everglades shows how one ecosystem can unravel when invasive predators and fast-spreading parasites appear at the same time. The Burmese python wiped out small animals, lungworm weakened native snakes, and the wetlands lost the balance that once protected it. Scientists now believe some ecosystems cannot fully recover once the damage becomes too deep. The message is simple: protecting nature means acting early, because saving a healthy ecosystem is always easier than rebuilding a broken one.